So life sciences or bioinformatics is one of our key markets, and what we bring to this market is really a couple of things. One is that we bring the scalability you need with the enormous amounts of data that is coming on into this space through next generation sequencing, for example. We offer the performance you need to be able to feed that data into the compute cluster to be analyzed. And we offer the operational optimization to do that very, very efficiently and at a low cost. You may have heard about genome sequencing, and there are a set of actually multiple generations of instruments out there already. They used to be generating sort of big images that then had to be analyzed in the compute cluster. What's happening now, and actually started happening last year, is that this data coming out of the instruments is no longer sort of a big image. It's the next step in the pipeline. So it's higher level information, and what that means from a storage standpoint is that it's a more mixed set of files and different operations you do on the file. So it's a more random environment and an unpredictable environment from the storage point of view. And this is being accelerated with the next generation that is now starting to hit the market. So users here really need a storage infrastructure that can scale in terms of capacity, but also can handle this changing environment on the fly. So you don't have to re-architect your storage environment. So we have a very unique architecture on a couple of different levels. Sort of the core of our architecture is that we actually accelerate the core functions of the file system in hardware. So that gives us the high performance, but also the predictability. So with that, we can support basically line rate of data out of our system. So we have a couple of 10 gig ports per node in our system. So that's high level, but it's also predictable. So what we can offer our bioinformatics customers is really the performance and the scalability. We do that with our architecture that has the hardware acceleration, but also a back end that is extremely scalable. So we can actually, with one of our high-end systems today, we can go up to 16 petabytes behind one system or one cluster. In most cases, you would cluster that for failover and high availability. The architecture is our head nodes, and behind our head nodes, we have a fiber channel network. And off the fiber channel network, we have RAID controllers to the actual storage. And it's an open architecture, so we have multiple vendors that can work with our head nodes. So that's another benefit of the BlueArc architecture. You're not locked in with the BlueArc architecture. We offer several options in terms of storage. Yeah, so in terms of operational efficiency, with our architecture and the way we also price our licenses, we are, like everybody else in the NAS market, basically pricing our software by the node. But the unique thing in our architecture is that you don't need that many nodes. So with other vendors, as you add capacity, you often need to add nodes as well. And that drives up the operational cost, both in terms of licenses, but also in terms of power and cooling, because it's another box that you need to manage out there. Yeah, for someone starting out in this space, maybe as a single researcher or a single lab with their first one or two instruments, they should start from the beginning to think about how to scale the storage environment. So they need to really look at a couple of years down the road what they want to have. Otherwise, they may end up with just a bunch of disks, and they will run into reliability problems, management problems. And eventually they're going to get into a situation where they need to be rescued. If they instead architect it from the beginning with something that can start at the level they need, but can easily scale, they will be much better off down the road. So where I think this whole space is going is, on one hand, everything is getting more affordable. You can run the experiments more affordable. The instruments are getting more affordable. So you'll continue to get this stream of data coming in that needs to be analyzed. And what's driving that in turn is really the move towards more personalized medicine and the work around agriculture in terms of producing more and better food out there. And all of that comes back to genome sequencing. And that is the ultimate force that is driving this space.